Determining the proper conduit type for underground parking garages necessitates referencing NFPA 88-1995. This standard provides detailed guidelines regarding acceptable conduit types for such environments, especially those classified as Class I Division Roman II locations. Since direct access to the NFPA 88-1995 standard is unavailable, obtaining a copy of this document is crucial for compliance and safety. The National Electrical Code, or NEC, often refers to NFPA 88 for specific requirements related to parking structures, particularly regarding hazard dislocation classifications and appropriate wiring methods. The NEC serves as a comprehensive guide for electrical installations, while NFPA 88 focuses specifically on parking structures. Understanding the interplay between these two standards is vital for electrical professionals working on parking garage projects. When selecting conduit for a Class I Division Roman II location within an underground parking garage, several factors must be considered. Firstly, the conduit must be suitable for the environmental conditions present, including potential exposure to moisture, chemicals, and physical damage. Secondly, the conduit must be approved for use in hazardous locations where flammable gases or vapors may be present. Thirdly, the conduit must meet the requirements of both the NEC and NFPA 88 regarding installation practices such as support spacing and sealing requirements. Common types of conduit used in hazardous locations include rigid metal conduit, intermediate metal conduit, and rigid non-metallic conduit. Rigid metal conduit, or RMC, is a heavy-duty option that provides excellent mechanical protection and is suitable for direct burial applications. Intermediate metal conduit, or IMC, is a lighter-weight alternative to RMC that offers similar protection at a lower cost. Rigid non-metallic conduit, or RNMC, is a non-metallic option that is resistant to corrosion and can be used in wet or corrosive environments. Each type of conduit has its own set of advantages and disadvantages, and the selection should be based on a careful evaluation of the specific application requirements. The NEC contains numerous articles that are relevant to the selection and installation of conduit in hazardous locations. Article 500 of the NEC provides general requirements for hazardous locations, including definitions of the various classes and divisions. Article 501 of the NEC provides specific requirements for Class I locations, including requirements for wiring methods, sealing, and grounding. Article 344 of the NEC covers rigid metal conduit, Article 342 covers intermediate metal conduit, and Article 352 covers rigid non-metallic conduit. In addition to the NEC, NFPA 70B recommended practice for electrical equipment maintenance offers guidance on maintaining electrical equipment in various types of facilities, including parking garages. Regular inspections and maintenance are essential for ensuring the continued safe and reliable operation of electrical systems in these environments. When installing conduit in an underground parking garage, proper sealing is crucial to prevent the ingress of flammable gases or vapors into the conduit system. Sealing fittings should be installed at strategic locations, such as where the conduit enters or exits a hazardous location. The sealing fittings must be properly installed and filled with a suitable sealing compound to create a gas-tight barrier. Grounding is another critical aspect of electrical safety in hazardous locations. All metal conduit and equipment enclosures must be properly grounded to provide a low impedance path for fault currents. Grounding helps to prevent electrical shock hazards and to minimize the risk of fire or explosion. The NEC contains detailed requirements for grounding and bonding in Article 250. The specific requirements for grounding in hazardous locations are found in Article 501.16. Proper support of conduit is also essential to prevent damage and maintain the integrity of the electrical system. Conduit should be supported at intervals specified in the NEC and in accordance with the manufacturer's instructions. Support should be designed to withstand the weight of the conduit and any cables or conductors installed within it. The NEC specifies minimum support spacing requirements for various types of conduit in Article 344.30 for rigid metal conduit, Article 342.30 for intermediate metal conduit, and Article 352.30 for rigid non-metallic conduit. It is important to consult these articles for specific requirements. Furthermore, the NEC requires that electrical equipment installed in hazardous locations be specifically listed for use in such locations. This listing ensures that the equipment has been tested and found to be suitable for the intended application. Equipment that is not listed for use in hazardous locations should not be installed in these areas. The listing mark of a recognized testing laboratory, such as Underwriters Laboratories or Intertech, indicates that the equipment has been properly evaluated and certified. When working on electrical installations in underground parking garages, it is essential to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment such as safety glasses, gloves, and hearing protection. It also includes de-energizing circuits before working on them and verifying that the circuits are de-energized using a suitable test instrument. Lockout/tagout procedures should be followed to prevent accidental re-energization of circuits. Electrical work in hazardous locations should only be performed by qualified and experienced electricians who are familiar with the applicable codes and standards. These professionals possess the knowledge and skills necessary to ensure that the electrical system is installed and maintained in a safe and compliant manner. In addition to the NEC and NFPA 88A, local building codes and regulations may also impose specific requirements for electrical installations in underground parking garages. It is important to consult with local authorities to ensure that all applicable requirements are met. These local codes may address issues such as fire protection, ventilation, and accessibility. Compliance with all applicable codes and standards is essential for ensuring the safety of building occupants and protecting property from damage. The design and installation of electrical systems in underground parking garages is a complex and challenging task that requires careful planning and attention to detail. A thorough understanding of the applicable codes and standards, as well as the specific environmental conditions present, is essential for ensuring a safe and reliable installation. Consulting with qualified electrical professionals is highly recommended to ensure that the electrical system meets all applicable requirements and is properly installed. Consider factors like temperature variations and potential for physical damage when selecting conduit materials. Also, always verify that all electrical components are rated for the specific hazardous location. The NEC provides guidelines for dirtying conductors based on ambient temperature, as outlined in Table 310.15. Ensure all boxes and fittings are also rated for the environment. Proper documentation of the electrical installation, including as-built drawings and equipment specifications, is essential for future maintenance and troubleshooting. This documentation should be kept in a safe and accessible location. Regular inspections and testing of the electrical system should be performed to identify any potential problems before they become serious. This includes testing of ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, RFCIs, as well as visual inspection of wiring and equipment. Any deficiencies identified during inspection should be promptly corrected. Furthermore, consider the long-term maintenance requirements of the electrical system when selecting equipment and materials. Choosing high-quality components that are designed for durability and longevity can help to minimize maintenance costs and downtime over the life of the system. Training of personnel who will be working on or near the electrical system is also essential. This training should cover topics such as electrical safety, lockout/tagout procedures, and the proper use of personal protective equipment. Properly trained personnel are better equipped to identify and address potential hazards, which can help to prevent accidents and injuries. When designing and installing electrical systems in underground parking garages, it is also important to consider the needs of electric vehicle charging. As electric vehicles become more popular, the demand for charging stations in parking garages is likely to increase. Providing adequate electrical capacity and infrastructure for charging stations can help to future-proof the parking garage and make it more attractive to tenants and customers. The NEC contains specific requirements for electric vehicle charging equipment in Article 625. Consider also the potential for corrosion in underground parking garages. The presence of moisture and chemicals can accelerate corrosion of metal components. Using corrosion-resistant materials and applying protective coatings can help to extend the life of the electrical system. The selection of appropriate wiring methods is also critical for preventing electrical failures. Wiring methods should be selected based on the specific environmental conditions present, as well as the anticipated loads. The NEC contains detailed requirements for wiring methods in Chapter 3. Furthermore, ensure that all electrical connections are properly made and tightened. Loose connections can cause overheating and electrical failures. Regular inspections should include checking the tightness of connections and retorquing them as necessary. Also, consider the potential for vandalism and theft when designing electrical systems in underground parking garages. Installing tamper-resistant equipment and providing adequate security measures can help to deter these activities. The use of conduit and enclosures can help to protect wiring and equipment from damage. Finally, remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest changes and to ensure that all electrical work is performed in accordance with the current requirements. Subscribing to industry publications and attending training courses can help to stay informed about the latest developments. Keep in mind the importance of proper labeling of all electrical equipment and circuits. This labeling should be clear and concise, and it should comply with the requirements of the NEC. Proper labeling helps to facilitate maintenance and troubleshooting, and it can also prevent accidents. Regular maintenance of the grounding system is also essential for ensuring electrical safety. This includes testing the continuity of grounding conductors and inspecting ground connections for corrosion or damage. The NEC specifies requirements for grounding electrode systems in Article 250.50. The use of surge protection devices is recommended to protect sensitive electronic equipment from voltage surges. Surge protection devices should be installed at the service entrance and at any other points where sensitive equipment is connected. The NEC contains requirements for surge protection devices in Article 280. Consider the potential for water accumulation in underground parking garages. Providing adequate drainage and waterproofing can help to prevent water damage to electrical equipment. Electrical equipment should be located above the expected water level whenever possible. When installing electrical equipment in wet locations, use enclosures that are rated for wet locations. The NEC defines wet locations in Article 100. Proper coordination of overcurrent protective devices, such as circuit breakers and fuses, is essential for preventing electrical faults from causing widespread damage. Overcurrent protective devices should be selected and coordinated to ensure that the smallest possible area is affected by a fault. The NEC contains requirements for overcurrent protection in Article 240. Also, be mindful of the potential for electromagnetic interference or EMI in underground parking garages. EMI can disrupt the operation of sensitive electronic equipment. Using shielded cables and equipment can help to minimize EMI. The NEC addresses EMI in Article 300.3. Ensure that all electrical work is inspected and approved by a qualified electrical inspector. An electrical inspection helps to ensure that the work has been performed in accordance with the applicable codes and standards. The electrical inspector will typically issue a certificate of compliance upon satisfactory completion of the inspection. Remember to consider the potential for future expansion when designing electrical systems in underground parking garages. Providing spare capacity in the electrical system can make it easier to accommodate future loads. This may include installing larger conduits and panels than are initially required. The NEC requires that electrical systems be designed to accommodate future loads in Article 220.87. When selecting electrical equipment, consider the energy efficiency of the equipment. Using energy-efficient equipment can help to reduce energy consumption and lower operating costs. Many electrical equipment manufacturers offer energy-efficient models that meet or exceed industry standards. When disposing of old electrical equipment, follow all applicable regulations and guidelines. Some electrical equipment may contain hazardous materials that require special handling and disposal procedures. Contact local authorities or waste management companies for information on proper disposal methods. Regularly review and update the electrical system documentation to reflect any changes or modifications that have been made. This documentation should include as-built drawings, equipment specifications, and maintenance records. Keeping the documentation up to date ensures that it remains accurate and useful. When working on electrical systems in underground parking garages, always be aware of the potential hazards and take appropriate precautions to protect yourself and others. Electrical work can be dangerous, and it is important to follow all safety procedures to prevent accidents and injuries. By following these guidelines, you can help to ensure the safe and reliable operation of electrical systems in underground parking garages.